Yeah, we are looking at the methods of integration, and then we are looking at the integrations involving partial fractions. Okay, and we are looking at the case here whereby the degree of the polynomial, the power of the polynomial of the numerator is higher than the denominator. It could be higher or equal. Look at this case now. The degree here, power 3, is also higher than the denominator. Okay, so the degree of numerator could be higher or equal to degree of denominator. Then in that case, we carry out polynomial divisions as a first step before the integration. Okay, and again, I've made a video on partial fraction. So please look for the watch out for the video and watch the video for the in-depth understanding of partial fraction. So let's look at the first method here, denominator of first degree. Want to see the method of integration, the first method, denominator of first degree. You can see the denominator here. The denominator is having power 1. Okay, that's 2x minus 3. So, and then you check the numerator is higher than the degree of what? The denominator. So the first step to this question is to carry out polynomial division. So 2x power 3 minus x squared minus x, then 2x minus 3. So what we'll do is that is for to look for a number that can multiply the first item and give us 2x power 3. And what's that number? S squared. So s squared times 2x, that's 2x power 3. S squared times this minus 3x squared. Then we can subtract. So that will give us this minus this cancel out. Then we have minus 1 minus 3. That's a plus 2x squared. Then we can bring this one down. So minus x. Okay. So what can we use also to multiply 2x so that to get 2x squared? So that's what? Plus x. X times this, 2x squared. X times this, minus 3x. So we have this minus this 0, and this minus this, that's a minus 1 or so, minus 3, that's a plus 2, plus 2x. Okay, here we can introduce 0 here and bring that 0 down. So plus what? Plus 0. Okay, so what can we use also to multiply 2x? To multiply 2x so that we get 2x here. So that's plus 1, and that will be 2x minus 3. So you can subtract, that will give you 0 minus 3. That's a 3 as the remainder. So this is what we call the quotient. This is called the quotient. This is called the quotient, and this is called the remainder. Okay. So your integral now, integrations of this problem will now become 2x minus 3 equal to integral. The first thing, you write your quotient first, s2 plus x plus 1, open brackets, then plus the remainder here, 3 over the divisor. This is what we call the divisor. So over the divider there, that's a 2x minus 3. Then close it. Okay? So in that case now, we can now integrate this, your dx. Okay? So which will be equal to the quotient. This will be equal to integral of s squared, that will be plus 1 over 3. Integral of x, that will be plus s, this is power 1 plus 1, that's 2 over 2. And the integral of dx, so 1 times dx, that's dx, that's equal to x. Then this one will be equal to, we can do separately, that will be, take the 3 outside, and that will be 1 over 2x minus 3. Okay? And then what I will do here, I'm going to do little manipulations here. The derivative of this one is 2. Okay? And we have 1 here. So I'm going to force this one to be 2, and then over what? Over 2. So let me say 1 times 2. Let's have 1 times 2. So 1 times 2. Okay, that 2 I introduced there already cancelled here. Okay, so the final answer will be equal to f3 over 3 plus s2 over 2 plus x, and then plus 3 over 2. Then the derivatives of the denominator, the numerator is equal to derivative of the denominator. So in that case now, it will be ln of the what? Of the denominator. Okay, you can use this, and if you like, you can use brackets. The choice is yours. I mean, you can use 3 over 2 ln brackets 2x minus 3. So the choice is yours. And then plus c. Plus c. S squared over 2 plus s3 over 3. So that's that on that. Then we want to look at the example 2, whereby the degree of the denominator is equal to the degree of the what? Of the denominator. So in that case also, we also carry out polynomial division. So 2x squared plus 11 divided by s squared plus 4. So what can we use to multiply s squared so that we can get 2x squared? So that is times 2. So 2x squared, 2 times this one plus 8. Then subtract, this will be 0 and this will be 3. So your integral of 2x squared plus 11 all over s squared plus 4 will be equal to the, what do we have here is the quotient. Okay, integral of everything here, then plus the 3 you have here, this is plus 3 over the one you are using to divide, which you call the divisor. Okay, over x2 plus 4 and then dx. Okay, so if we integrate this, this will give you 2x, and this will give you 3 into bracket dx over s squared plus 4. And this will be equal to 2x plus, this will give us arctan x over 2. Okay, then divide by what? Okay, we're having problem with how to integrate all this. I've done videos on 5 essential rules for integrations, and I've given the detailed illustration of how to integrate. So if you're having problem, please go to that video and watch it straight away. Okay, so that's that on this first method, where the denominator is of what? Is of first degree. Method 2. Let's look at method uh, for integration. We're looking at denominator of second degree. We have to look at the first one, first degree at the denominator. But now we want to look at the denominator of second degree. Okay, and which, so in this case now, and which does not resolve, which does not resolve into rational fractions. Okay, so in this case now we are looking at second method for integration, and then we're looking at the denominator of second degree, whereby it cannot be resolved into linear factor. Okay, so that's what we are looking to, which does not resolve into what? Rational fractions. Okay, and then we're looking at 2 cases here. Case 1, we're looking at 2 cases here. We're looking at case 1, in which the numerator is constant. That's case 1. And then case 2, in which the numerator is what? Is linear. Which numerator is linear. So let's play with that. And let's see the guide. 1. This is what we're looking at. K over AS squared plus BX plus C and DX. And this can be put, this can be expressed, this can be expressed, this can be expressed as, we can bring this K outside, and that will be equal to what? K over A dx over x plus alpha plus or minus beta. Okay, but don't worry. Let's see example to this case. Let's see example to this case to buttress what we have on the board. Look at this one example on this. Let's see example on this case. Integral of 5 over x squared minus 2x plus 10 dx. Okay, so this is what we are seeing, whereby you can't express this into a linear factor. Okay, the only way you can resolve this is into sum of squares using completing the square method. Okay, and the case one we are looking at, the numerator is what? Is 5. So let's see how this one goes. Let's see how that one goes. Integral of you can take the 5 out, take your 5 out, and that will be 1 over or dx over x squared minus 2x plus 10. Okay, so let's solve this as sum of squares using express this one in partial perfect square. And this will be equal to, take 1 here, we have minus here. Okay, then add half of 2, that's 1. Okay, so then whatever you had here, take it out. Okay, then plus what? Plus 10. So that's what we call x minus 1 squared, and that will be plus 9. So this is what we call sum of what? Sum of square. Okay, sum of squares. Okay, so sum of squares. So that's what we have done. Okay, because you cannot express this in linear form. Okay, you can't express it in linear form. So the only way you can do it is to express in perfect square. Okay, which is the sum of square. Okay, then after that you can go on with your integration, and that will be equal to this will be equal to 5 integral of dx over x minus 1 squared plus 9, and that will be equal to 5. That will be arctan x minus 1 over 3. Okay, then you divide by what? By the a plus c. So I think I've given all the rules. Please watch the video on that. So that's that on that question, and observe that in this case one, your numerator is constant. Your numerator is constant, and the denominator can be expressed into linear factor. Okay, dx equal to 2x squared plus 2x plus 5. Let's put 7 here. Yeah, 7. So that's the next question for that denominator of second degree. 7 over 2x squared plus 2x plus 5 dx. So if you check this question, you realize that the denominator is of what? Second degree, the power 2. Okay, and the numerator is what? Is a constant. That's case 1 in second method. So what we do is this is very simple. We can turn this to perfect square. Okay, can we take the 2 out? If we take 2 out, then we have x squared plus x plus 5 over 2. Okay, and that will be equal to 2 into brackets. Take one of this, plus is there, then half of the coefficient of x is what? 1 over 2. Okay, so whatever you had here, take it out, subtract 1 over 2 squared, then plus what? So this will give us 2 into brackets. This one times this one, 2x plus 1 over 2 or squared. Then this will give us plus 9 over 4. Plus 9 over 4. That's 1 over minus 1 over 4 plus 5 over 2. Okay. Then, and this minus goes in. If it goes in, then you have this will cancel out. You have 2x plus 1 squared. Then plus times 2, that will be 9. 2 here 1, 2 here 2, that's 9 over 2 for this case. I think it's 9 over 2. If you have not made mistakes, that's 9 over 2. Then we now have 7, you can go outside. Here, you can have your 7 outside, and that will be dx into brackets 2x plus 1 squared, and then plus 9 over 2. Plus 9 over 2. Okay? And that will be equal to arctan 2x plus 1. This one must be double, which will be equal to 9 over 2. If you want to make it double, that will be equal to 3 squared and then root 2 also squared. Okay, so that will be divided by 3 over root 2. Okay, 3 over 2. And then your a, and then 1 over what? 1 over 3 over root 2. Okay, then plus c. So, and that will give us arctan. This one will be root 2 into bracket 2x plus 1 over 3. Then this will give us root 2 over 3 plus c. Okay. Yeah, we are still in the method of integrations, method 2, denominator of second degree. Okay, and that case which does not resolve into what? Rational fraction. So if we check this one now, you can resolve into what? Into linear factor. Okay, and then we're looking at the case 2 of this method 2, where the numerator is a linear factor. So how do you do this? Okay, what we're going to do is to, if the numerator is linear expression, we put it to k times derivative of the denominator plus what? Plus L, where k, L can be determined by what? By inspection. Okay, so, and then you can go on, the integration can now be split into 2 parts, and then go on the integration. So look at the example we have here. This one, we have that the derivative of this is what? Is 2x. Okay, yeah. So times what? How can you, if I multiply, how can I get this x back? So times 2. That's my k. Because if I multiply, that will be times half. If I multiply half by that derivative, I'll get the first item. Okay, then plus what? Plus 3 equal to what? Equal to x squared plus 25. Okay, so that's that on that. So that will be equal to integral of what? Integral of half into bracket 2x plus 3 all over x squared plus 25. Then you can split now the integration into 2 parts, which will now become integral of half 2x over x squared plus 25 plus 3 over s squared plus 25. So dx dx. Okay, and this will be equal to, this half can go to the front, so we have half into bracket integral of what? 2x over s squared plus 25 plus this one, 3 can go outside, that will be dx over s squared plus 25. Okay, then the derivative of this one is 2x, which is equal to what? To the numerator, and that will be equal to half ln x squared plus 25. Okay, and then plus this will be equal to arctan, integral of this will be arctan x over 5. Okay, then you divide by what? 1 over what? 1 over a, 1 over 5, then plus what? Plus c. So that's that on that aspect. That's that on that aspect. I'll just try to 3 is here. We have 3 here already. So 3 over so this place will be equal to what, you have 3 there already. You have 3 there already, and then you are dividing by what? 1 over a. So a is 5, 1 over a. So that will give you that. So that's that. So that will be 3 over 5. Okay. So let's recap this case 2b of this second method. What this is saying is this: you have the denominator of second degree power 2. Okay, and then you have the numerator as a linear factor. Okay, and don't forget that the denominator you cannot resolve into what? Into a rational fraction. I mean, you can resolve into linear factor. Okay, so what the law is now saying is that it's going to be numerator is linear, so we put it to k times derivative of the denominator. Okay, and then plus what? Plus L, where K and L can be determined. So if you look at this one now, I don't know what my K will be, but I know the derivative is what? 2x. Put it there. So now we're thinking that what can I use to multiply this that will give me this first item? Okay, half is the best is number. So times 1 over 2, that will give you your x back, and then plus what? Plus 3. Then after that, you can now split the integration into 2 parts. Then go on with your integration. That's what we have done in that case. So let's take one more question on this aspect. So the question we're having now is integral of 3x minus 2. Okay, if you check it well, you realize that the derivative of this one is not equal to this, and you cannot even manipulate it. Okay, it's not equal to this. So we just have to fall back to this method that is going to be equal to integral of, I don't know my k, but let's get the derivative of this one, which is equal to what? 4x plus 2. Okay, so what can I put here? I can generate what? I can generate 3x. So that will be what? I think that will be 3 over 4. Yeah, that will be 3 over 4. 3 over 4 times 4x. 3 over 4 times 4x. Okay, so 4 will cancel, and then 3 times x, that's 3x. Okay, so I still need my L. I'm still coming back to that. I still need the L all over. This one we are going to resolve into perfect square, sum of square, and I think we've done this one before, but we'll do it again. Okay, let's do this one again. 2x squared plus 2x plus 5, which is equal to, take 2 out, then you have s squared plus 2, then plus 2x, then no, we take 2 out, s squared plus x plus 5 over 2. Okay, and that will give you 2 into brackets x, half of this is 1 over 2 plus 1 over 2 squared. Okay, then take this one, what you are adding, take it out, Subtract that also, and plus 5 over 2. Okay, then 2 into bracket, this will be equal to 2x plus 1 over 2 or square for this one. Then these two will give us minus 1 over 2. That's 1 over 4 plus 5 over 2. That's giving us 9 over 4. 9 over 4. So and that will give us, if you open this bracket, this is 4 here. This is 4 here. If this is 4, so I'm having 2x plus 1 square over 4 times 2, then plus 9 over 4 times 2. So 2 here 1, 2 here 2. So I'm having 2x plus 1 over what? Over 2. Plus what? Plus 9 over 2. So that's what that one will give me. Okay. Then we will come back here. This one will be equal to 2x squared plus 2x plus 5. So we now do something here. We've gotten the first one as 3x, but we are still having 3 over 4 times times 2. We want to get the L. Okay, so this will give me that's 6 over 4, which is what? 3 over 2. Okay, so what I will do now is to 3 over 2. Okay, what can I add to this number so I can get minus 2? So plus unknown, and then you go to what? You go to minus 2. So a equal to what? Minus 2 minus 3 over 2. That will be equal to minus 7 over 2. So that's this place will be what? This will be equal to minus 7 over 2. Okay, so then you can split the equation. 3 over 4 into bracket 4x plus 2 integral over 2x squared plus 2x plus 5. Okay, and then minus 7 over 2 integral of we have the expression there. That's 2x plus 1 all squared over what? Over 2 plus 9 over 2. Okay, this 3 over 4 can come outside. That's 3 over 4 integral 4x plus 2 all over 2x squared plus 2x plus 5. And then this 7 over 2 can also come outside. That's 7 over 2. Okay, 7 over 2. Then integral of what? Dx all over 2x plus 1 over 2. Okay, and then plus this one can be 3 squared over 2 all squared. Okay, and that will be equal to, this one will be, the derivative of this one is equal to this, and that will be 3 over 4 ln 2x squared plus 2x plus 5. Then this one will give me minus 7 over 2, and then this will be arctan 2x plus 1. So I can have it this way. Half into bracket 2x plus 1 all over 3 over root 2. Okay, then divide by a. 1 over what? 1 over a. So 1 over a, that will be root 2 times 3. So and then plus c. Plus c. So that's that on that.